Next, we will have a presentation of a very exciting, super interdisciplinary project at ETH Zurich, which is the CoVMass repetitive coronavirus testing at ETH Zurich. We have a set of talks shedding light on several aspects. Kickoff will be done by Professor Jörg Goldhahn. He is a professor at the Department of Health Sciences and Technology, where he's heading the Institute for Translational Medicine and the DTIP Clinical Trials Unit of ETH Zurich. Jörg, the floor is yours.
Thank you for this nice introduction. I'm really honored that we can present here our collaboration with NEXUS. And my part is more to give you some background information, some high-level information, and more specific details you will get during the next presentations by the team members. And I would like to inform you a little bit what are the, let's say, thoughts and considerations while we started working with NEXUS and how this interaction works. So it all started with the recommendation from the Gesundheitsdirektion Zurich that repetitive testing in situations with limited safety measures but increased infection risk, like in practical courses or lab work, is encouraged. And so you may remember that during the lockdown there was information presented by the canton, and the task force of ETH Zurich considered this for enabling a safe working environment. So one of the starting considerations was that we would like to establish test facilities to enable testing of around 10% of ETH members, students, and employees once per week. So this would mean that we'd have to have a system which could handle up to 3,000 participants per week. And another consideration, and very important one, was that we would like to do this with minimal human interaction to reduce potential virus spreading. You can imagine if you have a long queue waiting to drop off samples, then you get a new super spreading event by itself. So the goal was to enable or to set a low barrier test offer to break potential infection chain at ETH, and at the same time to enable a safe working and learning environment at ETH. And this all calls for automation. So having all those points in mind, we discussed at a very early stage, we need a system to fulfill all the different points. And so it's no surprise that we ended up with NEXUS. The other very important consideration was the test itself. There are many tests out there. We were looking for a test which would be user-friendly, but still very precise. Our colleagues from University of Zurich did all the pre-work here. So they did all the systematic testing of PCR saliva testing. And you see some of the features here presented at the slide. It has a higher sensitivity than a self-test. You can imagine if you do nasopharyngeal swabs every week, either after a few weeks you don't smell anything anymore, or you don't do it correct, which would lead to false results. It still has a high agreement with nasopharyngeal tests, and as we have observed in the past, much higher long-term compliance. So this was the second very important consideration. Now, one of the things that we discovered very early in the project is that we have a lot of interfaces, either within ETH or to the outside. And so this is one of the early flowcharts that J.D. Jörg came up with to exemplify how the process chain should look like. On the other side, we wanted to establish a very user-friendly system. So they should not see all of this complexity, but it had to be process-driven. So from signing up to the result, it has to be process-driven. At the same time, it should be a safe system. Remember what happened to meine Impfungen. So if you cannot guarantee a safe environment where privacy is protected, nobody will use it. So these are the kind of basic considerations we had at the beginning, and then we designed together a process which looks pretty simple. However, there's a lot of complexity behind. So if you would like to get a test at ETH, you would need to sign up at a NEXUS platform. And with signing up, we can already see, maneuver a little bit the capacity of the system. And then you would pick up your vial at one of the selector machines. We will hear from our colleagues from the machine building department how they designed it. And you can test yourself at home or in your own environment. So no need to test directly at the machines. You can drop off your sample in one of those collectors. Again, we'll hear from colleagues from machine building, how they designed it, what are the rationals. And then the specimen goes to the other part of NEXUS for pooling in a way that we can also depool and go back to the single specimens would be transported to our colleagues at the Institute for Virology at the University of Zurich. And finally, there's an automated reporting back to the participants, of course, but if necessary, also to the canton in case of a positive result. You see a very slim process, but you will hear more about complexity of the process from the different team members. But I would like to focus with the next few minutes is a little bit the complexity around the project. You all have followed, let's say, developments in COVID, and it was always a bit of a guesswork what happens next. So we always had to be prepared for new developments. And I'll show you a slide that has been also prepared by JD to show you a little bit the complexity. Here you can see on the upper part of the slide what happened around us. So the initial start for the project was the willingness of the Bund to pay asymptomatic testing and to encourage institutions to establish systems for repetitive testing. And then this was later on specified from BAG, then subsequently, limited teaching was allowed or contact quarantine canceled for companies with a test strategy. So this was, you see, also our starting point for going live. And as you have seen a few weeks ago, the cancellation of the home office obligation. So this happened around us. Then you see what happened at the ETH level and had an impact on our timeline. And finally, here in the lower part, you see what happened within the team. So in January, basically, we discussed very loosely, might be of interest to have our own test strategy. However, when we got this information that institutions are encouraged to build up their own test strategy, the whole project became more serious. And you see that at a very early stage, we contacted NEXUS to help us with setting up the infrastructure for a large-scale project at ETH, so bioinformatics as well as the testing. And we reached out to our colleagues in the machine building department to help us with pickup of samples and the collection of samples. And so beginning of March, we got the approval from the executive board of ETH to really fully run the project. So it took us basically from then on less than a month to get it up and running. We did controlled upscaling with some dry runs at the beginning to put all the pieces together. Did some small scale test runs and upscale the system in our live part. So this is slide should exemplify a little bit, how we developed the system and how we progressed within a very fast changing environment. With a more specific look at the live phase, you can see exactly when the ETH policy was changed. We were ready to test, and you may remember there was a town hall presentation of the project, and we got a limited uptake on purpose. So to be ready when people could come back to work or when the home office obligation was cancelled. And you see also that communication played an important role. You will hear at the end of this the session how we also utilized internal and external communication to have an impact on our sample numbers. And then so we upscaled to around 840, 860 samples. And now the big question is what happens during summer, exam session, start of the new semester. Nobody knows, but we have to be ready, and we got already this information from the COVID task force at ETH to be ready. Whatever happens in the future, you may have read about new virus mutants. So from our end, we are ready to continue, but of course, this is up to the environment, the outside environment, how we have to proceed. We also did challenge the system, so we had a very, very low number of positive results. So we had to challenge the system with some spike samples, and it worked. We also did a stress test, not on purpose, but more based on student behavior. They partied, and then we had to test them to resolve a potential mass spreading, and we could resolve it. So at this point, the system is up and running, and also potentially ready to be upscaled or even for takeover to other sites. So coming back to our initial considerations, can we scale the process? Yes, we can. So pickup, of course, that's the easy one. You can scale it up to larger numbers with having more selector machines. The same is true for the database. You can, of course, enlarge the database or duplicate to other sites. Collectors can be built or ordered. And the know-how for pooling is available. And so other universities, for instance, could take over some of the solutions. And we had already quite a number of requests. We discussed with them how we can help them, how we can provide our knowledge to other institutions. It's not, we don't want to make a big business out of it. We just want to help other institutions to resolve their situation and to make use of the knowledge that we gained throughout the process. I'd like to spend 1 or 2 minutes to the team, and it's a truly very interdisciplinary approach. You heard that I come from the ETH department with Yahel and JD Jäger. We have a very close collaboration with the SGU because we need to interact with them very closely. You see on this slide, it's all built around the NEXUS platform. But we also have the partners from machine building helping us to, with very specific and intelligent solutions to pick up samples, to collect samples, but also very small innovations for transporting samples. So it's a really big support, but also very good partners at the University of Zurich who do run all the testing. And so working as a team was really key to success. And at this point, I also would like to thank all of the team members, and I would like to hand over to the next team members to explain in more detail what happens within the project. Thank you for your attention.